Welcome. Today let's have a look at day 6 guard Gallivant of Advent of Code 2024. So for this problem, they give us a grid, two-dimensional, and these octothorpes or number symbols, hashtags, they represent obstacles. And this caret here represents a guard, and it also represents the direction it is traveling. So in this case, notice how it kind of indicates that it's going up. So it's allowed to go up. The guard is allowed to traverse up until it reaches an obstacle. And in that case, it has to form a turn right 90 degrees. And then it can take a step forward. So it can go up to here. So it would stop here because it's reached what they call an obstacle. So then it would have to turn to the right and until it reaches an obstacle. Turning right means it would be going down. Now it reaches another obstacle, turn right, 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 obstacle. However, now if you traverse as far as you can, you would exit the map. So they want to know how the exact wording is. They want to know the number of positions, the specific positions the guard would patrol before exiting the map. Yeah, here it is. How many distinct positions will the guard visit before leaving the mapped area? So, well, let's do it. It's not that bad. So what I recommend that we do is we everywhere the guard visits, we'll add that to a visited set, and we'll use a set because sometimes the guard's path will cross over his previous path, so we need to ensure not to double count them. So a set would help that quite well. So let's just go over how I did it. So this is the test data. So we're given periods and these number hashtags and this caret. For both the test and the data, the carets are kind of starts upwards, so that I guess it's helpful. What else? All right, so let's so I'll open the file, and I get ready to store the each row in a list, so a list of lists. So what I do is I add and enumerate here because what I want to do is I want to know where this starting point of the guard is. So that's why I add this RR here for the row. And I strip the new line character. I make a list out of the row so that each character is divided into its own cell. I append that to the graph here, the grid. And then I do something here. I use, so this L, I look for the index of the caret. And if it's found, it stores it in CC. Notice I have a try except here. So the index helps to find the location of where this caret is at, or the guard location is at. Now index, if the caret is not there, this will throw an error. So I just pass because it's not really important. And if we happen to find it, then we store the row and column of where the guard is located at. Okay. And then I store the length of the rows and the number of columns here. No problem. Now this is an important part here, this directions. So I put it in the order in which the guard would change directions. So for example, this first, what I've done here is I've done something like, I don't know if I can do this here. Let's see. Here. Maybe this, so this, and so if if the guard is traveling up, that means that the delta row is -1. So if we're at row 5, if we're going up, the next row going up would be 4. So that's why I have this -1 here and 0. Now, if we turn to the right, we're going this way now. Um, let's call this up and to the right. So for the right, we're not changing the row, but we are changing the column in a positive index. So that's why I wrote this in this location here. And then if you make a right, if you turn 90 degrees to the right when you're already going right, that means you're going to go down. So now we have this row with 1 and column of 0. And if you're already going down and you turn to the right, that means you're essentially going to the left, which means you're on the same row, but your column value is decreasing by 1. So that's why I put it in that direction. And then I use this I equals 0. This is the direction index, So this lets me know where I am, like what direction, keep track of which direction I'm traveling. Then I set the guard location to a period for convenience. The reason why it's important is because when you traverse the grid, at some point you may actually come back, and that's actually what happens. So when you come back, the way I set it up is I look for a period, an empty cell, and if you don't recognize the period, if it doesn't see a period, it'll think it's an obstacle. So but it isn't. It was just the starting location. So that's why I change it to a dot before I start the traversal. Here's the visited set. I'll be storing every cell the guard travel visits. So I first place the initial location of the guard here. And then I set dr, dc, the delta row, delta column, to whatever index, whatever direction index I'm at, and those values. Okay. So then it wasn't too bad here, this traversal. So while true. So I check so the current row, then I check going whatever direction I'm going, I don't know. So it's just variable. So if the next row, if the next location row and the next location column, and if we're in bounds, so this checks the bounds, and that new location is a period, it's okay to travel there. So I set it equal to, I add it to that. So I set r equal to r plus dr and c plus dc, and then I add it to the visited set. And then I just keep doing that as much as I can until something happens. So let's look at our data. So when we're traversing, there's two things that can happen that'll make it stop, that'll make it exit this loop. The two things are it hits an obstacle or it goes out of bounds of the map. So I check, okay, so once it exits out of this while loop, there's two options. So either we hit an obstacle or we have exited the map. So what I do at first is check if we hit an obstacle. So if we hit an obstacle, that means I need to turn right. So that means that's what I've done here. So I plus 1, so I is 0 here. We go to the next delta row, delta column. This means turn to the right. So this means stay on the right, stay on the same row, adjust the column. And that's why I have a mod 4 here, because potentially we can have 0, 1, 2, 3. We can have, if this is 3, if the direction index is 3, and we add 4, that'll go out of bounds. We want to go back to 0. So that's why I've added this here. And then just for convenience, I set drdc to whatever that is. to whatever the corresponding delta row delta column are for that index. And then if we're turning right, then we'd go back and start the loop again. However, if we have not seen the hashtag, that means we're outside of the map. So I just break and we're done. And I just print the length of E, and that's it. We can just test it right now just for you to see. What is it? Python prob 6. Oh, this is the input data. So on this one, I think we were looking for here 41. So that was that for this problem. For as far as part 2 is concerned, I will probably upload it in a different video because it was a little bit more complicated, and that'll make the video much longer. And I'm not a fan of long videos, either for myself as a being recorded, or myself or watching a video. Just if it's too long, I tend to lose focus. Okay. In any case, I hope you enjoyed it, and I hope it was educational for you. If you liked it or it was valuable, like or subscribe. Have a great day. Take care.